Hello friends, welcome to my channel Daily Solution. Today we will see work and energy standard 9 exercise. Please like, share and subscribe. First, write details answer. Explain the difference between potential energy and kinetic energy. Potential energy and kinetic energy. The energy possessed by a body on account of its specific state of position is called its potential energy. The energy possessed by a body due to its motion is called its kinetic energy. Second है, it occurs only in various forms such as gravitational potential energy and electrical potential energy, but work it not done till it is transformed into kinetic energy. Second, it occurs only in one form, and for doing work it does not have to be transformed into another form. Third, a potential energy is equal to mgh and kinetic energy is equal to 1 half mv square. Fourth, potential energy can be negative. Kinetic energy cannot be negative. उसके बाद है B. Derive the formula the for the kinetic energy of an object of mass m moving with velocity v. Consider a body of mass m moving with a uniform acceleration along straight line. If u is the initial velocity of a body, v is final velocity, and s is distance covered by during its change of velocity. We have v square is equal to u square plus twice of as. That's why v square minus u square is equal to 2as. S is equal to v square minus u square divided by 2a. First equation, if F is the net force acting on the body and W is work done by the force, W is equal to Fs. Second equation. Now F is equal to ma. Third equation. From equations 1, 2 and 3 we get W is equal to ma into v square minus u square divided by 2a. That's why is equal to 1 half m v square minus 2a square. For a body initial at rest u is equal to 0, therefore W is equal to 1 half mv square. C. Prove that the kinetic energy of a freely falling object on reaching the ground is nothing but transformation of its initial potential energy. Answer. If we release an object from a height, it gets pulled towards the earth because of the gravitational force. An object falling slow under the influence of gravitational force is called free fall. Kinetic and potential energies of an object of mass m falling freely from height h when the object is at different heights a, b, and c. Height is h, distance x, a to b and b to c, h minus x. Let us calculate the energies of object at A, B and C. When the object is stationary at A, initial velocity is u is equal to 0. Therefore, kinetic energy is equal to 1 half mass into velocity square is equal to 1 half m u square. U is 0, that's why kinetic energy is equal to 0 and potential energy is equal to mgh. Therefore, total energy is equal to kinetic energy plus potential energy is equal to 0 plus mgh. Total energy mgh, first equation at the point of A. After that, let the velocity of object be Vb when it reaches at B, having fallen through a distance x. U is equal to 0, S is equal to x, A is equal to g. V square is equal to U square plus twice AS. Vb square is equal to 0 plus 2gs. Vb square is equal to 2gs. Therefore, kinetic energy is equal to 1 half mv square is equal to 1 half m vb is equal to mgx. Kinetic energy is equal to mgx. Height of the object when at B is equal to h minus x. Therefore, potential energy is equal to mg h minus x. Potential energy is equal to mgh minus mgx. Total energy is equal to kinetic energy plus potential energy. Here, mgx kinetic energy and potential energy mgs minus mgx. Total energy is equal to mgh. Second, after the let the velocity of the object be vc when it reaches the ground near point C. U is equal to 0, S is equal to h, A is equal to g. V square is equal to U square plus twice AS. Vc square is equal to 0 plus 2gh. Kinetic energy is equal to 1 half mvc square is equal to 1 half m 2gh. Kinetic energy mgh. The height of object from the ground point C is h is equal to 0. Potential energy is equal to mgh is equal to 0. Total energy is equal to kinetic energy plus potential energy mgh is plus 0. Total energy mgh. Third equation. From equation 1, 2 and 3 we see that the total energy of the object is the same at points A, B, C. Thus, every object has potential energy when it is a height above the ground and As the object falls towards the ground on reaching the ground, all the potential energy gets converted to kinetic energy, but at point during the fall the total energy remains constant. D. Determine the amount of work done when an object is displaced at an angle of 30 degree with respect to the direction of the applied force. Answer A. A constant force acting on a body as displacement of the body theta angle between F and S. Dis, यहाँ पे displacement of body O to P direction of the force O to Q. Now theta is equal to O R and the cos theta is equal to O R and O Q. O R is equal to O Q cos theta F cos theta. This is the component of the force in the direction of the displacement. Work done by the force W is equal to F cos theta S is equal to Fs cos theta. सेकंड है 30 डिग्री एंगल में डिस्प्लेसमेंट ऑफ द बॉडी ओ पी डायरेक्शन ऑफ फोर्स ओ क्यू cos theta is equal to OS divided by OP. OS is equal to S cos theta. This is the component of displacement in the direction of the force. Work done by the force W is equal to Fs cos theta is equal to Fs cos theta. Theta is equal to 30 degree. Cos theta root 3 divided by 2. Work done is equal to Fs root 3 divided by 2. Second है if an object of zero momentum, does it have kinetic energy? Explain your answer. Kinetic energy of a body of mass m and speed v. Kinetic energy is equal to 1/2 mv square is equal to mv square m square v square 2m is equal to p square divided by 2m, where p is equal to mv is the momentum of body. It follows that if p is equal to 0, the kinetic energy of body is 0. Next is, why is work done on an object moving with uniform circular motion is 0? The work done is positive when the force acting on the body and the displacement of body have same direction. Second, the work done is negative when force acting on the body and displacement of the body have opposite direction. Third, the work done is zero when there is no displacement of body due to applied force, or when the force acting on the body and the displacement of the body are perpendicular to each other, as in uniform circular motion where the force is always towards the center of the circle and the displacement is always tangential. Question second. Choose one or more correct alternatives. A. For work done to be performed, energy must be. Answer is transfer from one place to another. Second, concentrated transfer from one type to another. And third, destroy. Answer is the first one. Transfer from one place to another. B. Joule is the unit of force, work, power and energy. Joule is the unit of work and energy. Third, which of the forces involved in dragging a heavy object and a smooth horizontal surface have the same magnitude? The horizontal applied force, gravitational force, reaction force in vertical direction, fourth force of फ्रिक्शन. इसका आंसर है थर्ड, रिएक्शन फोर्स इन वर्टिकल डायरेक्शन एंड ग्रेविटेशनल फोर्स एंड रिएक्शन फोर्स इन वर्टिकल डायरेक्शन. उसके बाद है पावर इज मेजर ऑफ the rapidity with which work is done. Second, amount of energy required to perform the work. Third, the slowness with which work is performed. Fourth, length of the time. इसका आंसर है the rapidity with which work is done and the slowness with which work is performed. E. While dragging or lifting an object, negative work is done by the applied force, gravitational force. Third, frictional force. Fourth, reaction force. इसका आंसर है ग्रेविटेशनल फोर्स एंड फ्रिक्शन फोर्स. उसके बाद है रीराइट द फॉलोइंग सेंटेंस यूजिंग प्रॉपर अल्टरनेटिव्स. द potential energy of your body is least when you are sitting on chair, sitting on ground, sleeping on the ground, standing on the ground. इसका आंसर है sleeping on the ground. The total energy of an object falling freely towards the ground decreases, remains unchanged, increases. Fourth, increases in the beginning and then decreases. इसका आंसर है remains unchanged. C. If we increases the velocity of a car moving on a flat surface to 4 times its original speed, its potential energy will be twice its original energy, will not change, will be 4 times its original energy, will be 16 times its original energy. इसका आंसर है will not change. उसके बाद है D. The work done on an object does not depends on displacement, applied force, initial velocity of the object, the angle between force and displacement. इसका आंसर है initial velocity of the object. Fourth question is study the following activity and answer the questions. Study देखिए, take 2 aluminum channels of different lengths. Place the lower ends of the channels on the floor and hold their upper ends at the same height. Third, now take 2 balls of the same size and weight and release them from the top end of the channel. They will roll down and cover the same distance. Questions. At the moment of releasing the balls, which in energy do the ball have? Answer: potential energy. As the balls roll down, which energy is converted into which other form of energy? Potential energy to kinetic energy. Why do the balls cover the same distance on rolling down? They have the same speed. What is the form of the initial total energy of the balls? Kinetic energy. Fifth, which law related to energy does the above activity demonstrate? Explain. Answer: law of conservation of energy. Explanation: energy can neither be created nor destroyed. It can be converted from one form into another. Thus, the total amount of energy is the universe always remains constant. इसके जो प्रॉब्लम्स है वो नेक्स्ट वीडियो में आपको मिल जाएंगे, तो आपको स्टे ट्यून रहना होगा. Thank you for watching video. Please like, share and subscribe.